Quantum computers are a type of computing device that use the principles of quantum mechanics to perform calculations that are beyond the reach of classical computers. Unlike classical computers, which use bits to store and process information, quantum computers use quantum bits, or qubits. The basic idea of a qubit is that it can exist in multiple states at the same time, known as superposition. This means that a qubit can be in the state of 0 and 1 simultaneously, leading to an exponential increase in the number of possible states compared to classical bits. Another key quantum property is entanglement, where the state of one qubit is dependent on the state of another qubit. The combination of superposition and entanglement enables quantum computers to perform certain calculations much faster than classical computers. One of the most famous applications of quantum computers is Shor's algorithm, which can factor large numbers exponentially faster than the best classical algorithms. This has implications for cryptography, as many public key encryption algorithms rely on the difficulty of factoring large numbers. Quantum computers also use a different computing paradigm known as quantum parallelism, where many computations are performed simultaneously. This allows quantum computers to perform certain calculations much faster than classical computers. There are several approaches to building quantum computers, including superconducting circuits, trapped ions, and topological qubits. Each approach has its own strengths and weaknesses, and it is unclear which approach will become dominant in the long term. One of the challenges of building a quantum computer is that qubits are highly sensitive to their environment, and even small disturbances can cause errors in the computation. This is known as quantum decoherence, and it makes it difficult to maintain the coherence of the qubits for long enough to perform meaningful calculations. Despite these challenges, there has been significant progress in building practical quantum computers in recent years, and many companies and research institutions are investing in the development of this technology. While it is still early days for quantum computers, it is clear that they have the potential to transform many areas of science and technology, from cryptography and simulation to optimization and machine learning. Overall, quantum computers represent a radical departure from classical computing, and they have the potential to solve some of the most challenging problems in science and technology. However, significant technical and scientific challenges remain, and it will likely be many years before quantum computers become a widespread technology.